Good day, engineers. So para sa video natin ngayon is sasagutan natin yung sample problem number 1. So this is for the topic analysis of singly reinforced beam. So start natin yung discussion. So sabi dito sa sample problem 1, a reinforced concrete beam has a base of 300 mm and a height of 450 mm, reinforced with 4 diameter 25 mm tension bars at the bottom. The beam has an effective depth of 387.5 mm. If the concrete compressive strength is 25 megapascals and the steel yield strength is 414 megapascal, determine the following. So, A, the depth of the compression block, B, the actual steel stress, and C, the ultimate moment capacity of the beam. So, for this sample problem, i-drawing natin yung beam. So, eto siya. So, syempre, we have the tension bars, sabi doon at the bottom. So, siguro tong beam na to is magre-resist ng positive moment, kaya yung tension bars niya is nasa baba. Then, you have a base of 300 mm and a height of 450 mm. Then, meron daw tayo ditong F'(C) or yung concrete compressive strength, which is 25 megapascals, and a steel yield strength Fy of 414 megapascals. Then, yung effective depth natin, so that is the distance from the extreme compression fiber to the centroid of our reinforcement. So, since single layer lang yan, so that will be 387.5 mm. So, syempre, inassume natin na single layer yan. So, wala pa naman kasi tayo dun sa part ng provisions for the spacing ng bars. So, dito, since analysis lang pa lang naman to and wala pa tayo dun sa part ng design, so we assume na single layer pa lang naman siya. Then, pinapadetermine sa atin yung depth of compression block. So, yun yung A. Yung actual steel stress, which is the Fs actual. Then, yung ultimate moment capacity of the beam, which is the Mu. So, to start, syempre, sabi dun sa steps natin, we always assume the tension steel yields. So, syempre, after assuming that our tension still yields, so we will start with the static equation C is equal to T. So, syempre, galing lang yan sa stress diagram na to. So, we'll disregard the A balance here. This is just A. Syempre, yan yung depth of compression block. So, for this one, ang ilalabas na sa atin ng static equation na to is just a theoretical value for our depth of compression block kasi i-validate pa natin kung totoo yung assumption na tension still yields. So for this one, we will be having, so since wala naman kahit anong butas yung compression side natin, so dito, so ibig sabihin valid yung 0.85 F'C kasi buo pa yung concrete doon. So ganyan yung itsura niya pag 3D. So, nakaganyan yun. So, valid yung 0.85 F'Cab kasi para siyang rectangular prism. So, that is C is equal to T. Yung C natin is 0.85 of our F'C. So, ang ilalabas sa atin dito is A theoretical times B is equal to AS. So, syempre, since ang assumption natin is the steels are yielding, so we will use the value Fy since the steel yields. So, kunin muna natin si AS. So, ang AS natin dyan is equal to a value 4 na 4 times pi over 4 times 25 squared. So, 4 na 25 mm. So, So our AS now will be equivalent to a value of 625 pi. So, ito na yung value ng AS natin. So, this is in mm squared. So, after getting the value of AS, i-arrange na natin tong static equation natin na galing sa stress diagram natin na C is equal to T. So, that is A theoretical is equal to AS Fy divided by 0.85 of F prime CB. So, substituting the value ng AS, Fy, ng F prime C at B. So, we have AS na 625 pi times our Fy, which is 414. Then, divided by 0.85 times our F prime C is 25 times our base is 300. So, for this one, our A theoretical will be equivalent to a value of, that is 127.5117. So, this is in mm. So, yan ngayon yung A theoretical natin. So, to determine our C theoretical, so syempre dun tayo sa NSEP provision which states that A theoretical or A is equal to the beta 1 C. So that is theoretical yung C na mapapalabas natin dito. Then arranging the term, we will have C theoretical is equal to A theoretical over our beta 1. So, A theoretical natin, 127.5117 divided by 0.85. So, 0.85 yung ginamit kong beta 1 kasi yung F prime C natin is 25 megapascal. So, our F prime C is in the bracket na that is greater than 17 but it is less than 28. So, ibig sabihin, pag ganito yung condition, our beta 1 is equal to 0.85. So, from this one, we could have the value of our C theoretical equivalent to 150.0137 38. So that is 150.0138. So this is in mm. So yan ngayon yung ating C theoretical. So syempre, to validate all of our assumptions, we could have or we could check it by getting our Fs actual. So titignan natin kung yung Fs actual natin is lalagpas dun sa given natin na Fy. So yun yung magpapatunay na nag-yield talaga yung steel natin. So para makuha natin yung Fs actual, syempre pwede yan manggaling dun sa ating strain diagram, or kung kabisado nyo yung formula, okay lang naman. Pero much better if you know where to get it if you forgot the formula. So, syempre dito galing yan sa strain diagram natin. So, this 0.003. Then, this will be our C. And this is the value of D. Then, this will correspond to our strain ng steel. So, syempre, yung strain ng steel natin dyan, that is the Fs over our Es. So, using similar triangles, so, syempre, itong height na to, this could be D minus C. So, Using that height, we could get 0.003 divided by C is equal to, so next is, that is yung Fs over Es na natin sa ilalim. So that is Fs over Res divided by D minus C. So syempre, etong Es natin bababa, yung Fs natin is re-retain. So pag sinimplify natin yan, that is 0.003 over C is equal to Fs over Es times D minus C. So syempre, imumultiply natin to papunta ron para yung Fs na lang matira sa kabilang side. So that will be our Fs is equal now to, so 0.003 Es times D minus C over RC. So syempre yung Es doon, that will correspond to 200,000 megapascal. So syempre magiging Fs now is equal to, so 0.003 times 200,000 is a value 600 times D minus C divided by C. So ngayon, check natin yung mga values na kailangan nating ilagay. So ang D natin is 387.5 and yung C theoretical natin is ito. So ang mapapalabas mo dito sa equation na to, by the way, is a theoretical value din. So isin natin, so this is Fs theoretical din, kasi hindi pa natin na-prove. Magiging actual lang yan kung na-prove natin yung assumption na steels are yielding. So that is 600 times RD, which is 387. Check natin, 387.5 minus our C, which is 150.0138 divided by 150.0138. So our Fs theoretical will be equivalent to a value of, that is 949.8574. This is in megapascals. And as you can see, this is greater than our Fy. Therefore, we have verified the assumption that the steels are yielding. So that is therefore Sy. So that stands for steel yields. So we can say that the Fs theoretical is equal to our Fs actual, and also our A actual or our A theoretical is equal to our A actual, and our C theoretical is equal to our C actual. So yun yung na-prove natin. So yung mga hinahanap natin na depth of compression block is A actual, which is a value 127.5117. That is in mm. Then yung Fs actual na hinahanap natin is equal to a value 949.8574 megapascal. So ito ngayon yung dalawang values na pinapahanap sa atin sa problem natin. Ngayon, to determine yung last value na pinapahanap sa atin, so that is the ultimate moment. So since we have proven na steel yields, kailangan na ngayon natin hanapin yung reduction factor. So to find our reduction factor, syempre dadaan muna tayo sa paghanap ng net tensile strain. Pero paano natin hahanapin si net tensile strain? Syempre mahanap natin si net tensile strain by using our strain diagram. Pero syempre, ang gagamitin natin is hindi epsilon sub s. dapat yung epsilon sub t. Pero as you can see, dito sa given natin na beam, single layer yung beam natin. Ibig sabihin, yung D natin, so, yung D natin is equal sa ating D sub T. So, pag dinerive natin yung equation ng ating epsilon sub T, okay lang naman kung kabisaduhin nyo, pero kung makakalimutan nyo is much better kung lagi nyong ilalagay yung strain diagram. So, that is, syempre, we take this one as C, yung C actual na natin. And we take this one as our dt. So as you can see, same pattern, this will be dt minus our C actual. So getting the similar triangles and using ratio and proportion, so that is 0.003 divided by our C actual. That is equal to the epsilon sub t divided by our dt minus our C actual. So that will be a value, epsilon sub t now will be equivalent to 0.003 times dt minus C actual divided by our C actual. So substituting all the values, so we have 0.003 times our dt 387.5 minus yung C actual natin na nakuha kanina. So yung 150.0138. So that is 150.0138 divided by a value 150.0138. So our epsilon sub t now will be equivalent to a value of, that is 0.00479. So dito 6 decimals tayo para mapalabas natin yung 4 significant figures dyan. So that will be our epsilon sub t. And as you can see, this is lesser than 0.005 but greater than our value 0. Or check natin yung Fy over Es natin. So ang Fy over Es natin is 414 divided by 200,000, which is a value na 0.00207. So yan kasi yung ET sub y natin. So therefore, andun tayo sa part ng reduction factor na nasa transition zone tayo. Or nandun tayo sa stage na nasa transition zone. So, ibig sabihin, kailangan nating i-derive or kailangan nating kunin yung equation through the NSEP provision under the transition zone, o kung hindi man at hindi kabisado or hindi open NSCP yung exam, much better to solve it this way na ang gagamitin natin is yung diagram from our concept or from our previous lecture. So yung diagram na yun is ito. So ito ngayon yung gagamitin natin to determine our strength reduction factor or yung phi. So syempre, we are on the part ng 0.65 or yung others. So, ito yung linya lang napapansinin natin. So, syempre, we are on the transition zone. So, we will get the equation of this line using the values given. So, syempre, yung part na to is meron na tayong value niyan. So, that is, so, yung ETY natin is ito, yung 0.00207. So, yung X niyan, 0.00207. Tapos, yung Y is 0.65. Then, yung nandito, lagi yung 0.005 and 0.9. So, syempre, mas madali sa atin kasi ngayon may mga values na. So, gamitin natin yung equation of the line, Y is equal to MX plus RB. Yung M natin dyan is always rise over the run. So, the rise will be 0.9 minus 0.65. Then, our run will be 0.005 minus 0.00207. So, the value of our slope will be equivalent to 25,000 over 293. So, yan yung slope natin ngayon. Then, yung y-intercept natin is makukuha lang natin through the equation y is equal to 25,000 over 293 plus b or x plus b. So, syempre, yung y natin dyan, kumuha lang tayo ng isang ordered pair dito sa line natin kahit alin dun sa dalawa. So, syempre, kunin natin yung 0.005 and 0.9. So, that will be yung y natin is 0.9 is equal to 25,000 over 293 times yung 0.005 plus b. So, our y-intercept now will be equivalent to a value of 1387 over 2930. So, yan ngayon yung y-intercept natin. So, as you can see, kompleto na natin yung equation. Isiset na lang natin na yung y is equal sa reduction factor and yung x is equal dun sa epsilon sub t na nakuha natin. So, that will be the reduction factor is equal to 25,000 over 293 epsilon sub t plus our 1387 over 2930. So, our reduction factor now will be equivalent to a value 25,000 over 293 times our epsilon sub t, which is 0.004749 plus 1387 over 2930. So, yan ngayon yung equation natin. So, we could have a reduction factor equivalent now to 0.8786. So, yan ngayon yung ating reduction factor. So, now we can proceed in getting the value of our moment or yung nominal moment muna. So, manggagaling yung nominal moment na yon dito sa stress diagram natin. So, it's either kunin mo siya on the part of the compression or on the part of the tension. Ngayon, kunin natin siya on the part of the tension side. So, that will be our nominal moment. So, syempre, nominal pa lang ilalabas sa'yo ng stress diagram. Hindi pa siya yung ultimate. So, that will be equivalent now to, so sa tension tayo, times yung moment arm na D minus A over 2. So, sa tension force natin, syempre, that is the AS. And ang gagamitin nating stress is yung Fy. Kasi na-prove natin that steels are yielding. So, that will be times D minus RA over 2. So, that will be equivalent now to a value na yung AS natin is 625 pi. Then, yung Fy natin is 414 megapascal. Then, yung D natin is 387.5 minus yung A natin na nakuha kanina, yung actual value na. So, that is 127.5117. That is 127.5117 divided by 2. Ngayon, syempre, itong values na to is i-multiply natin by 1 over 1,000 squared. So, syempre kasi, ang lalabas na value mo dyan, kung ito is mm squared, ito is Newton per mm squared, kasi megapascal yan, then this one is mm. So, syempre, ito magka-cancel out. So, Newton mm yan. Kailangan nating value is ma-convert into kilonewton meter. Kaya, i-divide natin lagi yan by 1,000 squared or i-multiply natin yan by 1 over 1,000 squared. So, our nominal moment coming from this equation will be 263.1674. So, this will be in kilonewton meter. Then, para na dun sa ultimate moment na hinahanap natin, so that is just the reduction factor times our value mn. So, that will be 0.8786 times our mn, 263.1674. So, that will be a value of mu equivalent to 231.2189. So, this is in kilonewton meter. So, ito na ngayon yung hinahanap natin na ultimate moment of our beam. So, that will be all for our sample problem number 1 for the analysis of singly reinforced beam. Again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.